So we're gonna test the hardenability of steel. So using a Jominy test. So this is a sample which is used to do the test. The dimension of the sample should be 20 millimeter in diameter and 100 millimeter in length. So the idea of this test, we need to heat up the sample to a temperature when we can form austenite in the sample, and then we have to leave it for a while in the furnace to make sure the temperature is going to be uniform across the sample. Okay, and then we leave it there for at least 15 to 20 minutes. The temperature, as we can see here in the furnace, we set it to about 920, and that's the required temperature for this grade of steel, which is 1020 mild steel, to form austenite. And then after that, we're gonna take out the sample, and then we gonna cool this end quickly using water quenching, and then leave the rest of the sample to cool gradually. So here we have the quenching device. Okay, so from this location, this is the water, we call it the water fountain. So the water, it is gonna touching the end of the sample, and then it's allowing this end to cool very quickly. By having that, we are forming the austenite to form martensite because of rapid cooling, and then the rest of the sample, it's gonna have a different microstructure. Okay, so now we're gonna start placing the sample in the furnace. And then we will leave it there for at least 20 minutes.
20 minutes later.
So now we have left the sample for around 20 minutes, and now we're gonna take it out. Before taking the sample out, we start the water here. So the fountain here, the water, we have to control it just to make sure it's gonna touch the end of the sample. Okay, so now take it out of the furnace. We should be careful. And see that layer at the top, it is the carbon. See, now it is the carbon. See that layer, it is carbon. So now we can see this, the first part cool down. And now we can see the variation in the color. This is because of the cooler rate is different. So here is the highest and here is the lowest. So two factors which is very important, or three factors which is very important for this test. Number one is the time. So we should take the sample out from the furnace to here within 5 seconds. That's critical one. And the second one, it is about the water flow. So as we said, it should touch the end of the sample. And the third one, it's about the duration. So we should leave the sample to cool down for at least 10 minutes, okay? Or longer until it reaches room temperature. But if we need to do it quicker, we can leave it there for at least 10 minutes, and then we can take it out and then put it in water. That should be enough to develop the variations in the microstructure. So we're gonna have, as we said, martensite at the end, and less martensite while we go to the top. Okay. So now this sample, it has been cooled down, and what we need to do now, we need to grind it and then do hardness testing to see the variation in the properties due to the heat treatment. So now what we're gonna start measuring the hardness along the length of the sample. So here we mark this location, and this time we're gonna use a hardness tester, Rockwell hardness tester, using scale C. So for scale C, we're gonna apply 150 kilogram, and we're gonna use an indenter which has a cone shape, and it is made of diamond. And also similar to the scale B, we're gonna apply an initial load which is equivalent to 10 kilogram force. So now I'm gonna place the sample and move it close to the indenter. So this is almost location 1. Yeah, so this is the initial loading. define the set point and then start the test. So here what we are getting, like here based on the black numbers, it is about 61 to 62.5 rock wall C. Okay, and now we're gonna move to another location. So for example, if we go to location number 4 and then also bring the sample in contact with the indenter and then apply the initial load and define the set point and then start the test. And just if you come here, like you can see the indentation at location 1, it's quite visible, that indentation mark there. And we are expecting the indentation mark to be increased as we are moving far from the end, because the hardness it is decreasing. And see now, the hardness is lower, so it is about 59 rock wall C. Okay, now let's move to location 6. So again, we are applying the initial load, define the set point, and then start the test. So now we can see it is lower, so it is about 55 rock wall C. Okay, we're gonna move to location 8 and bring the sample in contact with the indenter, apply the initial load, and now we start the test. So this variation in the hardness is due to the martensite formation. So because this end has been subjected to very rapid cooling, so therefore there is martensite, and as we're moving to the end of the sample or to the beginning of the sample, it is less and less martensite. So here is the location here. It's about 55 because they are quite close to the previous location. And now we're gonna go to location, let's say 11, which is a bit far. So now the hardness is much lower, so it is about 47 rock wall C. Okay, and now if we're gonna move to the beginning of the sample, so now it is location 15, as you can see here. So we're gonna do the indentation here. So this is about 46, which means like the rest of the sample has almost the same hardness.